This video I would like to explain how a program load is happening. So in Linux system, when we build, and then after the build, when we execute the program, how the load is happening and how the program is loading into the memory, and then how the process descriptor is creating. So that is what we are going to see in this video. So welcome all of you. So here I am using a simple C program. So you can see this is a hello world program. So this one I am using to explain the concept. So here I am compiling it with the GCC compiler. So I compiled it. Now we can see the a.out, the output file here. So this one actually, when we execute in the UI like this, a.out, so when we start execution, actually the UI comes. So here the user interface will check whether the file is a valid executable file or not, and then after that it will hand over the control to the loader, and how loader is loading the entire program to the memory space. So to understand that, first of all we need to check the type of a.out file. So there is a tool called file. So when we use this, we will get the file type. So this is a ELF file, means executable linkable format file. So this is an executable file. So now there is another file, read ELF. So this one ELF a.out. So by using this read ELF tool, we can see that what are the contents. So in order to use it properly, we need to provide the parameter -a. Yeah. Now we can see that there are different sections. So how the a.out file is structured. So we can see here different sections involved here. So there are sections with the type load. So the load type section, when we look, we can see that this read and executable section, and then there are read only section, and then there are read write section. So like this, there are different sections. So based on this information, the loader will load the sections to the memory. Based on this header information, the kernel loader will load the program into memory. So now the memory structure will look like this. So right now we have a storage called a.out file, the executable file. So loader is loading the code segment and data segment to the memory. Here in the ELF data structure, we can see that there is a section called dynamic section. So here you can see that the needed. So this shared library libc.so.6, this library is needed. So this library, so the kernel loader will take care about this. So when this library is available in the memory, then it will not load a new instance, but it will resolve the function pointers which are used in the executable file with the available libc library. If this library is not loaded into the memory, then a new this library will be loaded. So this kind of information will also be there. So when we check this in the program, you can see that after loading the SO file, the code and data segment got expanded. So the code segment and also code from shared library, data segment, there might be some data from shared library. So After loading the shared libraries, the both code and data segment section will get expanded. After the kernel load the code and data segment into the memory, now after this the control will pass to a new component in the kernel, process manager. So now it looks like this. So process manager assign an ID to this executable component loaded into the memory. So that one we called a process ID. So all the relevant informations, not only the process ID, the priority, so everything, all the relevant information related to this executable stored in a structure that is called the process descriptor. After this, actually the process manager take this process and queue it into the scheduler. So the scheduler will schedule it later. So now the when the scheduler invokes this process, there is a bootstrap code in the code segment that will run first. So that bootstrap code will execute and then the entire address space will be formed. So now the process looks like this. So all the stack, heap, everything will be formed, and then if there is a constructor that will execute, and then the control will be moved to the main function. So right now we have code segment, data segment, and all other heap and stack, everything in the memory. So the program starts execution. So actually this is the process of loading a program into memory. So initially the UI where we are typing dot slash the executable name, the UI will check the file whether it is a valid file or not, and then the control will pass to the kernel loader. Kernel loader will load the code and data segment from the ELF file to the memory, and then it will assign it to the process manager. So there will be a process ID for each executable. So and after that when the turn come, so when the sequence of this program executes, then first the bootstrap code in the code segment will execute. It will do the initialization process, and it will form the stack and heap. The complete address space will be formed, and then control will transfer to the main function. So this is all about the loading and initialization of a program. So next video we will see how to see a running program in a Linux environment. So thank you for watching.